second or higher order differential equations. That's what we're going to deal with here. So non-homogeneous or inhomogeneous equations. So we have y double prime equals to y prime plus 2y plus 3 exponential 2x. So what does that mean? We have y double prime, that's a second order differential equation. In previous videos, we dealt with the first order differential equations. So now we're moving forward. Now, what do we do here? So we're going to have to rearrange our equation. So rearranging our equation means what? So we have y double prime minus y prime minus 2y equals to 3 exponential 2x. All right? So this is how we rearrange it, by having 3 exponential 2x on the right side of the equal sign, what we call the source term. All right? So now the source term can be an exponential function, could be a trigonometric function, it could be also a polynomial or other functions, okay? But in this case, we're dealing with an exponential function. So the next thing to do is what? Is to make this equation to become a homogeneous equation. So homogeneous equation, that means we have y double prime minus y prime minus 2y equals to 0. So we have our homogeneous equation, okay? So now how do we deal with the homogeneous equation is not to turn it into a characteristic equation, all right? So let's go again. So we have k squared minus k minus 2 equals to 0. So we have here our characteristic equation. So far, so good? All right, so far, so good. So this is what we have now. The k could have been a z, could have been an m or anything else. So it's just that in this case, we're using k. All right? So now how do we solve for this trinomial here? So with a trinomial, we can factor it or we can use the quadratic formula if we want, we deem so. But in this case, can we factor that? Yes. We have a trinomial, and then we have what? A, which is 1, B, which is -1, C, which is -2. So A times C, which is -2. So we're going to use the AC method. So that means 1 times -2, which is -2. So we're basically looking for two numbers that will multiply, give you -2, and then add up gives you what? -1. What would be those two numbers? It's going to be -2 and +1. Because -2 times +1 is going to give us -2. And then when you add them up, you get -1. So then you end up with k minus 2 times k plus 1 equals to 0. Okay? And then now from here, k equals to +2, and then k equals to -1. Okay? So far, so good? All right. Now, once we get the values here, the zeros, or the solutions for these for this equation here, how do we set up our homogeneous solution? Because remember, we're solving for the homogeneous equation in this case. So the homogeneous, so we call it y sub h equals to what? C1 exponential -x plus C2 exponential +2x. So this is what we have for our homogeneous solution. Okay? So far, so good. Now, it doesn't matter which one comes first. So the 2x could have been here, the -1x could have been the other side. But, for me, I just put them in order from the smallest to the largest. Okay? We good? And then what's going to happen? So once we get this, now we have to find our particular solution. So we need our homogeneous solution. We need our particular solution in order to find our final solution. The addition of those two will give you our final solution. So how do we get to the particular solution? To get to the particular solution, we have to make an approach, okay? Or sometimes we call it also ansatz, okay? So approach or ansatz. So that means what? So we will be inspired from our source term before we do that. So we have an exponential function, we're going to use that. If we did have a trigonometric function, we're going to use that. If we did have a polynomial, we're going to use that. But in this case, that's what we're going to use. So in this case, it's going to be a exponential to be inspired by 2x. So the same 2x exponential that we have here, that's what we're going to use. Now, pause. Before we continue, what do we need to find out? We need to find out if this particular solution, after we find the y prime and then the y double prime that we need, are we going to get a contradiction or we're going to be going forward to be able to get the A. In this case, let me give you a tip. And what is that tip? The tip is that when you look at your source term, and then when you look at your solution, the homogeneous solution, if any of these solutions contains 2x, exponential 2x, exponential 2x, like in this case here, this one's -1, but this one is 2x, is the same thing as this one here. It doesn't matter the 3 or the C2, okay? Just the exponential function here. Because they are the same thing, so that means you will be ending up with a contradiction. A contradiction that we also call a resonance. Because we have a resonance, we're going to change the way we're going to write the y sub p. And how do we do that? So y sub p now is going to become a of x exponential 2x. The only thing we did was that a, which is a constant, becomes now a function. So because of resonance, okay, or contradiction, as we were going to do it. Now, we need to find our y prime, we need to find our y double prime. So let's go at it. So here we are. So let's go for our y prime. So y prime is going to give us what? So we have a x of x times exponential 2x. So we got two functions here. So we had to find the derivative of the multiplication of two functions, the product of two functions. That means f prime times g plus g prime times f. Okay, we did that before, so we're going to do that. So the f prime is going to give us what? It's going to give us a prime. Okay, times exponential 2x, all right, plus, then what's the derivative of exponential 2x? Is going to be 2 exponential 2x, and then we will multiply that by a of x, so exponential 2x. Okay, that's how we do that. Okay, we good so far? Now we got to find the y double prime. The y double prime, because we need those two in order to get back into this equation and find our a. That's the reason why we're doing it. So let's go at it. So here also we have the derivative. You have two functions, a prime and then exponential 2x, and then we have to do the same thing that we did before with the derivative of the product of two functions. So the derivative of a prime is going to give us what? A double prime times exponential 2x plus the derivative of this one here is 2 then times a prime exponential 2x. All right? And then we got to do the same thing here. What's the derivative of this one here? So it's going to give us 2 a prime, all right, times exponential 2x. And then the derivative of this one here is then 2 exponential 2x times the 2 which is already here. That will give us 4 a of x exponential 2x. We good? Now, we have our y prime, we have our y double prime, we do have our y. So what do we have to do? We get back into this equation here and substitute in there. So we have a double prime exponential 2x plus 2a prime exponential 2x plus 2a prime exponential 2x. I'm just rewriting this one here, okay, exponential 2x, and then minus y prime, so that means minus y prime is this one here, so minus a prime exponential 2x minus 2a of x exponential 2x, okay, and then minus 2 times y, so y is this one here, so it's minus 2a of x exponential 2x, and that should be equal to, ladies and gentlemen, 3 exponential 2x. Okay? So now we have this. Now we have to combine, subtract, add whatever we can. So we have a double prime exponential 2x, which has nobody to play with. And then now we go with 2a prime, 4a prime minus a prime. That will give us what? Plus 3 a prime exponential 2x. And now we have 4a of x exponential this, which is the same thing as this, but this is negative, negative. So that means this, and that we crossed out. And everything will be equal to what? 3 exponential 2x. All right? So now here we are. What can we do again? We can simplify by taking away the exponential 2x, which is all around. So a double prime plus 3a prime, this is equal to 3. All right? Now what are we solving for? Do not forget that we're solving for a, right? So because we're solving for a, so we have to find the integral, because these are derivatives, and then you have to do the inversion of that. So you invert it, so you find the integral, because those two are, one is the invert of the other one, okay? So then this one will give us a prime plus 3a equals to what? 3x. So now we're getting very close. We're looking for a, so we do not need this. So we end up with 3a equals to 3x. 3a equals to 3x. So that means a is equal to x. So if a equals to x, what is our y sub p? It is equal to y sub p is equal to then x exponential 2x. So what does that mean? That means our solution, our final solution, y, which is equal to y sub p plus y sub h. So that would be equal to, then what is y sub h is this one here. So c1 exponential negative x plus c2 exponential 2x, then plus the y sub p, which is x exponential 2x. Ladies and gentlemen, now you are done. Okay? Now you're done, fully done.